Hello everyone, and welcome to College Algebra review for Chapter 8 with functions. Let's take a look at a few problems as we review our material on functions. Here we're graphing a quadratic function, and we're identifying the vertex and the axis of symmetry. Okay, you'll notice on the right here we have the general form for the vertex form of a quadratic. Okay, so this is our vertex form. Remember when we have our h and k, we take opposite of h, regular k, and that gives us our vertex. And then we have our a. A determines whether we open up or down. So if a is greater than 0, we open up. When a is less than 0, we open down. And remember, a also determines narrow versus wide, right? So for narrow, if we have our absolute value of a greater than 1, this will end up becoming a narrower parabola. And if a is between 0 and 1, as a fraction, it would be wider. Okay. Okay, so let's look at our current problem. We have our function x minus 1 quantity squared minus 6. Okay, so quickly we identify where the vertex is. Okay, opposite of this number, so it's a -1, so opposite would be +1, and regular of this number, it's a -6. Okay, so at 1, -6, we have our vertex. Okay, and axis of symmetry would be the vertical line going through the vertex. Okay, so vertical line is in the form of x equals, so x equals 1. Okay, so we can't just stop with the vertex. We have to identify a couple other points. So we could go immediately to the left or to the right of our vertex. Okay, we can plug in, for example, let's plug in 0. We'll end up with the y-intercept. So if we plug in 0, then we have, let's say we do 0 minus 1 squared minus 6. So that gives us -1 squared minus 6, which -1 squared is 1. 1 minus 6 is -5. So that means we have a point at 0, -5. Okay, 0, -5. And remember, because we have our axis of symmetry, we can mirror that point immediately. One point to the right of the vertex would also be at a 5, so 2, -5. And so our parabola would be something like this. Okay, and your axis of symmetry. Okay, very good. Any issues, you can practice that, do various forms on it, but this is the general setup for the problem. Okay, let's take a look at our next one. We're graphing a piecewise defined function for f of x is equal to 2x for x is less than 0, and f of x is equal to x squared plus 4 for x is greater than or equal to 0. Okay, one thing to note when we have these conditions, look at where the x is less than or it could be greater than. If it's a plain symbol, just remember at that point, you'll put an open circle. If it's a greater than or equal to or less than or equal to, then you'll have a closed circle at that point. Okay, I like to keep track of these with XY tables. Okay, so for the case where x is less than 0, we're going to graph 2x, which is a linear function. Okay, so let's graph 0 and then less than 0, so -1. And 2 points should be enough for a linear function. If we plug in 0, 2 times 0 is 0. -1, 2 times -1 is -2. Okay, so we have the open circle at 0, 0. And then -1, -2. We have our point. So this is going to continue downwards in this direction. It's a linear graph. Okay, now let's look at for the second part of our piecewise. For x is greater than or equal to 0. So again, let's put 0 down. And then we're going to go, we can do 1 to the right. Okay, so putting in 0, 0 squared is 0, plus 4 is 4. 1 squared is 1, plus 4 is 5. Okay, so again, let's graph this. 0, 4, closed circle, and then 1, 5. Okay, and we recognize this is a quadratic, so then this would continue in this manner. Okay, so there's our piecewise function. Okay, this one we have our domain for a rational function. So when it's a rational function, remember the domain is going to be all real numbers except where the denominator equals 0. Okay, so we're going to take the denominator, set it equal to 0, and then solve it. And then once we get those points, we know that the domain would be all real numbers except for those values. Now this is a quadratic. It appears we could try solving this through any number of means for solving a quadratic equation. But we could try doing factoring. So let's try that. This looks like an AC method, right? So A times C, 6 times -5 is -30. So what multiplies to -30 and adds up to +15? So we go through our progression for 30, and then we could work with the sign. So we know 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. Okay, now what would give us a -30 when multiplied, and then add up to 13, +13. Looks like a couple close ones, but at the end I think it's going to be this one. -2 and a +15. Be careful with that one. That 3 and 10 could have thrown us off. But it would be the -2 and the +15. Okay, so let's go into our AC method, the factoring technique I show you guys. So 6x squared, I'm just going to take the 6x portion. So write the 6x twice. Put your two numbers underneath, -2 and the +15. And now just reduce where possible, right? So we reduce by 2. That would be a 1 and 3, so 3x minus 1. And then this one we could divide by 3, it looks like. 6 divided by 3 is 2. 15 divided by 3 is 5, so 2x plus 5. Okay, and so we're setting these factors equal to 0, and now we solve. Okay, so we can just set each factor equal to 0. So 3x minus 1 equals 0. Add the 1, divide by 3. So x equals 1/3. 2x plus 5 equals 0. Subtract 5, divide by 2. Okay, so x equals -5/2. Okay, so now we could go into our expression for the domain. So we know that we would have our set builder notation, all x's such that x does not equal 1/3 and x does not equal -5/2. Okay, and that would be it. That would be our domain. Okay, let's take a look at our next one. Find the domain. Here we have a square root function, radical. Technically, this should say f of x equals root 11 minus 4x. There's a little typo there. My apologies. So when we see a square root function, just remember the radicand, right? The expression underneath the square root has to be greater than or equal to 0. Okay, that would be our initial setup for it. And then we could go into interval notation later on. So we take our expression. Now we just solve it. Okay, we can minus the 11 both sides. So we have -4x greater than or equal to -11 divided by -4. Now we're dividing both sides of an inequality by a negative. So remember the special rule, flip the sign. Negative divided by negative is positive. So we have x is less than or equal to 11/4. Okay, so what does that look like in terms of the interval notation? So less than or equal to 11/4, that means we would have 11/4 with our square bracket, and we're going to the left because we're less than, and so going to the left, that direction will be -infinity. Okay, so interval notation would be parentheses, -infinity, 11/4, and we have the square bracket to close it off. Okay, find f of g of x. Okay, f of g of x, this means this is a composite function. Okay, very simply, all it means is take the g function, plug it into our f function, and then simplify as much as possible. Okay, so in this problem, we're going to take our g of x, the 2x minus 5, and we're going to replace the x in our f of x with 2x minus 5. Okay, so that means what we'll do is we'll take the 2x minus 5, plug it in, which means we'll have to square it. And then at the end, we'll plus 4. Okay, so remember 2x minus 5 times 2x minus 5 is what we're going to do because we have the quantity squared, and then we'll add the 4 later on. Okay, so FOIL this. 2x times 2x would be 4x squared. 2x times -5 is -10x. -5 times 2x is another -10x. -5 times -5 is a positive 25. Okay, combine like terms. So we have 4x squared minus 20x. And then we have the plus 25 and the plus 24 plus 29. And that's it. Very straightforward. Just be careful when you're expanding and then combining like terms. Okay, well, that's about it. Okay, so that concludes our review for Chapter 8. Okay, hope this video will help you when you're studying. And that's about it. Have a great day. Have a great night. We'll see you soon.